So let's say I roll this ball and we stop it right about there. You can clearly see the position of the ball, but could you tell me its speed and momentum? We live in a world full of tiny objects which scientists refer to as particles. For example, electrons are subatomic particles that exist in orbitals around nuclei. We are also surrounded by waves in the form of light and sound. When two wave pulses interact with each other, they create interference patterns, meaning that their crests join together and their troughs join together. By studying quantum mechanics, scientists were able to deduce that matter is both a particle and a wave, meaning that particles have wave-like behavior. For example, when disturbing water, we can see that the waves are fed through these two openings and create interference patterns as they disperse outward. Now, if we shoot electrons out of a laser, we can see that they also disperse outward, creating similar interference patterns. Interesting. Because particles behave like waves, Heisenberg's uncertainty principle states that it's impossible to know the position and momentum of a particle at the same time. Heisenberg's uncertainty principle can be represented by this expression. The change in position times the change in momentum must be greater than or equal to Planck's constant over 4 pi, which basically means that the product of these two has to be greater than some really small number. The certainty of position and momentum are inversely proportional to each other, meaning that as the certainty of momentum increases, the certainty of the position decreases. Because particles behave like waves, trying to find the position of the particle becomes difficult since the particle is at every crest and every trough simultaneously. The momentum tells us the speed of an object moving in a certain direction. Now let's pretend that I'm a nucleus of an atom and these two dancers are two electrons, and we add some strobe lights to simulate electron movement. As the dancers move horizontally, we can be relatively sure about their position, but not their momentum. So what if the electrons were to move randomly around the nucleus as they normally would? Their angular momentum becomes more certain, while their exact position becomes less certain. If we truly want to understand how the world works, we must keep studying quantum mechanics and follow Heisenberg's footsteps by exploring the little things, because in the end, they matter the most.